Hello, my name is William McKillop, and this is Lab 2. So, introduction. The purpose of this lab is to measure how the magnetic field is affected by distance, compare true distances and predicted distances, and understand magnetic fields visually using glow script. So, quick look into the results. When the magnetometer is approaching the magnet, the magnetic field Bx increases. As the magnetometer gets far away from the magnet, Bx approaches 0, and we got n equals negative 2.0098, and mu equals 7.861 amps times meter squared. So we have the Biot-Savart law, and we have the dependence distance formula and linearization formula. These are our physical concepts. So assumptions and errors. We assume that no other electric fields were acting on the magnetometer other than the Earth and the magnet. Assume the phone was on the north-south axis. Human error in the measurements or the orientation of the phone. So the experiment, we use our phone as the magnetometer, lined the phone to true north. Then we measured the distance between the magnet and the phone and recorded the magnetic field at that point. And our initial conditions were that the phone was aligned with the north, bar magnet was aligned with the magnetometer, system and surroundings. The system was the bar magnet and surroundings was everything else. So here we have the data, and we have LNR and LNBX, and here we have Y, and our slope is the n value. And also we just have additional data over here. So what we did was find the distance of the bar magnet at varying bx and find by by Earth, find bx, by, bz, and correct by due to the Earth. And here we have the total magnetic field on the bottom right of the bottom table. So calculations. We have ln bx equals ln k plus n times ln r, and we have our n value, and then we raised both sides to e to get k equals 1.572 times 10 to the negative 6, and we found the magnitude of the magnetic field of the bar, and we found r equals 1 meter, and mu equals 7.861 amps times meter squared. And here's our code. And so we have the surrounding magnetic field, which are the arrows above and to the sides of the magnet. And here's our code to the side as well. Similarities and differences. On-axis vectors point in the direction of mu, and perpendicular vectors point in the direction opposite of mu. And the differences, the theoretical value for B equals 3.565 e to the negative 6t. And measured value for B equals 4.91 e to the negative 5t. So for our what if questions, what if we did not orientate our magnetometer to align with true north? How would the results change? So the Earth's magnetic field will interfere with our bar magnet's magnetic field, which will skew the data to incorrect numbers. And the second one, what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The bar magnetic field would double and be in the same direction. So that's it. Thank